Welcome to this tutorial. Where we left off in the previous video, we'd created a quite simple application using Speedment that connected to a database and computed the average and variance of the salary of two different tables, grouped by the gender column. So we could get how much men versus women were making and what the variance of those were. And we can show that it was quite easy. You got full type safety right in this application. But what we're going to talk about today is performance. So if we add a little thing around this called benchmark, we can see how fast this is. So let's run a benchmark and let's say that this is the main file. The method I'm in is called main, and this is what I want you to do. Next, we can close this in. So this will try and call this lambda and then measure how much time it takes. We also need to return something, so I'm going to return null. And just to get a little bit of a scale for this, we're going to do this 10 times. So I'm going to say like this, and we close that out in, so like this. So now when we run this benchmark, it's going to do the aggregation 10 times and measure how much time it takes. And remember in the previous video, I told you that the aggregator object is reusable. So we're going to create the aggregation object once and then invoke it 10 different times. So let's run it. And now it's done. You can see it took 28 seconds to do this aggregation 10 times. So it's 2.8 seconds per aggregation. And that's quite slow, isn't it? Well, the reason for this is that first, we have quite a big data set here, and it's also located in a relational database that's mostly stored on disk. So whenever we need to do an aggregation, first we need to send the query to that database. It needs to retrieve the interval that we're looking for from disk, potentially using an index, but still, it still has to load all the data. And then it has to send it back to the client so the client can do the aggregation. And that's not very good. I mean, aggregations you want to do probably in memory. You want to do it as fast as possible because it's considering a lot of data. So I'm going to show you how easy it is to switch a Speedment application into an in-memory application without doing any modifications on the database side. So in this example, I'm going to add 2 lines of code to turn it into an in-memory application. First, we need to enable the in-memory bundle that's bundled together with Speedment. So we call with bundle in-memory bundle.class. And this will enable all the in-memory functionality of Speedment. But just adding this doesn't actually tell Speedment to pull in the data into memory. We're still going, if we execute this, it's still going to send it to SQL and get a response back. So we need to tell Speedment when to load it into memory. And in this case, we want to do it immediately as the application is built. So we just write app get all throw data store components and then load. So this will tell Speedment that when you reach this line, start pulling in data and don't go ahead until you have finished. We could also specify a custom executor service here if we wanted to do it using a different method than the for join pool. So now, if we just try and run this again, we can see what kind of speed it gets when it's running in memory. And here it's done. So first off, the pulling of data into memory, it took about 11 seconds to load it all into memory. And then it's about 3.1 million entities that's loaded. If we look down, the actual query took 7.9 seconds to do it 10 times. So we went from about half a minute down to 7 seconds by doing it in memory instead. So even including the load time, it's still faster. So can we do this even faster? Well, at 7.9 seconds is still quite slow if you're talking in memory, considering all the data is already in the memory when we start the aggregation. So the reason why it's quite slow still is because what we have here is a one-to-many relations. We have an employee table and we have a salary table. And for each employee, there are multiple salaries. So whenever it's doing the aggregation, it has to look at multiple salaries for each employee. So it considers the employee, then looks up all the salaries, takes the next employee, looks up all the salaries, and so on. And that's not very efficient. But if we look at this operation here, we can see that it's an inner join. And inner joins, they are symmetric. So they actually work the same thing if we flip the operands. So in this case, we could optimize this knowing how the data is structured by putting the salary first. So I'm going to do that. Now I have replaced these, but we still see that there is an error here with the where statement. And the reason for this is that the where has to consider the lastly added table. So in this case, it's the employee table that the where statement is considering. So we can't actually filter on the salary column of the salary table here. But it works just as well if we just move this down into the stream itself. I'm going to go here and add it as a filter instead. And then we need to tell it which table we are filtering on. So we compose it by taking tuple to getter 0. Now we see that this is fine. So the reason for this is that this predicate is operating on a salary entity. But here we have a tuple to salary employee. So we have to tell it that to get the salary from the tuple to, take the first element of it. Next, we also need to modify the collector. So it uses salary, comma, employee. Now that's done as well. So we can try and run the application. So remember, last time it took 7.9 seconds. And it's done. And the entire aggregation now took 2.27 seconds for doing 10 operations. So we haven't really changed anything in the actual logic. The first thing we did was adding the in-memory bundle and enabling it by calling the load method. And this would pull in all the data in memory and then do all the operations in memory instead. And the second thing we did was that we replaced the salary and employee order so that we go from 1 to 1 instead of 1 to many. And now we have over 10 times faster aggregation. So thank you for watching.